topic we are going to see here is multiplier bit pair recoding. So it's a part of the fast multiplication where you go for bit pair recoding means, and moreover there are a lot of types in the fast multiplication like carry sum order and so on. So here we are going to see the bit pair recoding, and upcoming sessions we will see the modified bit pair recoding, modified Booth algorithm also. We are going for a bit pair recoding method means because of it's a method where reduce the number of bits and increase the multiplication process very fast in the computers. So here and also follow the concept of n by 2 here. That means number of steps will be reduced. For example, if you will solve the problem with 6 steps in the it will go for bit pair recoding. We can consider the 3 bits and so on, and reduce the 3 bits here. Within 3 bits, 3 steps you can get the solution here. So before understanding this example, let's go for the table. So this table is very important here. When you go for digital electronics or this kind of computer architecture topics, we have one derivative table is there. We have to follow this one. The table start like I plus 1, I followed by I minus 1. That is a multiply bit pair, and this is a multiply bit on the right, and also multiply and selected position. So this table you have to remember if you want to solve any unsigned numbers or multiply or signed numbers like that. So if at all 0 0 0 0, you have to take the result of 0 into m bit. So here is I plus 1, I value, and I minus 1, and so on. 0 0 1 means followed by plus 1 into m, and there will be 8 values like this, and 0 1 1 0 means plus 1 into m, and 0 1 1 means plus 2 into m multiplying, and 1 0 1 0 0 1 0 0 means minus 2 into m, and 1 0 1 means minus 1 into m, and 1 1 0 means minus 1 into m. At last 1 1 means 0 into m. So these results we have to apply when you go for bit pair recoding. Just go for small example here. I am repeating also. Consider that we have an example called 110 here. So if you want to derive any bit pair recoding, assume that we have to write the right bit LSB bit 0 by default. We have to add 0. This is not substitution, so writing 0. And right side we have to write the most significant value 1 here. Any sum. If you want to do any bit pair recording, you can write 0 as well as the 1 here. So total already have 5. So now we have totally 7 bits. Now you can go for the bit pair recording. So start from here. It start from right to left only. This is I plus 1 value, I plus 1. This is I value. This is I minus 1. This is a 1 keep on changing. And when you go for next operation, you can leave this base, leave bit and write it. And when you write the results, you can write directly to the I bit. So 1 0 0. What is the result of 1 0 0? That is minus 2. So I am writing the 0. Ith bit value here minus 2 like that. Then leaving 1 bit, you can go for 101. What is the result for 101 here? 101 result is minus 1. So I am writing the here. If you move this, what happens? This is I plus 1. This is I. This is I minus 1. Then we can write the minus 1 here and keep on going. Leave the other bit and go the last bit 111. So 111 means just now I told you the 0. So I can write 0. 0 is anything 0. So I can write the 0, and this is I plus 1 value, I value, and I minus 1. 0 I am writing and completing the step here. So remember this table, then only you can derive any bit pair recoding algorithm. We are going means to make fast multiplication and reduce the number of steps here. Now we go for the example. So consider that we are going to solve the problem called unsigned numbers 13 into minus 6. One is positive and one is negative. So you know the binary value of minus 13 plus 13 is if at all plus not given also you can consider as 13 only, plus positive number only. 110 where you go minus 6 binary value is 011. So first we have to normalize and equalize the table digits with the help of digital electronics. So you can write by default you can write add 1 bit and write 0010 like that. Then minus 6 means what? You have to find the plus 6, minus 6 means you have to find the 1's complement, then add 1. At last you will get the minus 6 value. So if you get minus 6 value, it comes 1010. We are substituting here. So here, and moreover, if you want to go this bit pair coding, these digits are not substitution rule saying. So what I am going to means if at all plus 13, you can write the sign bit called 0. And at all if at all negative numbers come, you can write the 1 here. If at all sign bit minus 6, minus means negative number means 1 by default. So now you can go for the solution of the problem. So remembering, so whenever you have a digits, first of all you have to equalize 4 bits means here also 4 bits is there. If not there, you can add 0 anything. And later you can go for if at all plus positive number, you can write 0 sign bit, and minus 6 means what is it? 1 bit. So now you can go for the solution. Let's go for solution. So simple and easy. So here I written already here 2 times save. Here we have a number, so I am going to substitute the minus 6 value, and here I am going to multiply. So first we go for the minus 6. Just now I told you, so minus 6 equivalent value is 110. So you can write right side 0 and left side you can write 1. So you can go predict the values, say same value coming. So 11010, so you'll get the answer of minus 2, minus 1, 0. And there will be a difference between the normal multiplication and this bit pair recoding, because here when you write the result in multiplication write continuously, but here you write leaving 2 bits like that. So that is a very important here. So first step I am going to multiply here. First step, what is that? Minus 2. When you go for minus 2, what is the problem? And you have to think, first there are 5 digits. So 5 digits into 2, you have to ask for a digital utterance, you have to 10 bits. So let them see. So if at all minus 2 come, what you have to means, first take the multipliers. This multiplies 1's complement and find the 2's complement, then you can multiply with the 10. If at all plus 2 directly you can multiply with 10. So you remember, the first step what you can do is in the multipliers take the 2's complement, 1's convert to 1's complement, add 1 2's complement and multiply with 10. You will get the answer of 110. So here we have 5 digits. Remaining digits we fill with the default to 11. So totally for 10 digit will be there. I am parallelly filling with 11111. So remembering, first step we are into minus 2. That's the reason we are going to do with convert to 2's complement. Here I cannot write the 2's complement and multiply with 10. That is 10 binary value of plus 2. 2's complement like that. And next step minus 1. So if you want to minus 1, what you can do means you can go convert to 2's complement now. So 0 1 0, if you convert, what happens? 1 0 0 1 0 plus add 1. So what result we are getting, that we are going to apply here, that is 0 0 1 1. So remembering 0 0 1 1. So this is a minus 1 comes, directly you can find the 2's complement of sub 2 here. So then last, if any number is 0 0, so by default I am getting 0 0 0 0 0 filled with remaining bits 0. So keep in mind when you write the result here, first leaving 2 bits and write the next partial product, and also leaving the 2 bits and write the next product. This is a way of unsigned number where at last we can go for addition. So all numbers get addition. So here 0 1 1 plus 1 0 carry. So carry 1 will be the 1 plus 1 0. Again carry 1 you substituting here, and 1 here again followed directly 1 you can write 1 plus 1 0. Again carry will come here, carry 1 come here. So 1 instead of you can write 1, again carry 1 be there, again write 1, and again 1 will be there, again write 1. At last 1 will be there. This 1 is carry, you can ignore it. So finally add the sum, you will get the result of 111 0 11 0 0 1 0. This is equivalent of minus 78. You know answer of manually, you know 13 into minus 6 is minus 78. This is equivalent to binary of minus 78. This is a way we are going to solve the problem. So remember, when you go for first to find the multipliers, bit pair combinations, where you can write the leave the bit 3 bits, add 0, and here write the sign bit 1 by default for all the sum, and go for factoring. After bit pair coding, you can substitute and go for the multiplication. When you go for minus 2 come, directly you can find the, if at all plus 2 you can go to directly 2's complement. If directly you can multiply with 1 0, but if at all minus 2 you can go for find the 2's complement, that is convert to 1's complement, add plus 1 and substitute the value. So common set the bits we are writing 111 here default. Here also common set the bit we are writing 111 here. What are the result we are getting? We remaining fill the 11 here. At last add all the values, we will get the result of bit pair recoding. So thank you for watching this video. Please subscribe, comment in the post box channel, and keep on connecting with the social media.